We open the faucet and it's always there, clean, safe, and abundant. Water, the essence of life. We need it every day. We can turn on the faucet in our kitchen right now to wash a bowl of vegetables or fruits. We drink water, bath in it, and cook with it. Our easy access to water makes it appear nearly limitless. But but we often forget that safe drinking water serves ways before it gets to our tap, before the pipes that lead it to our homes, even before the complicated process of treatments and disinfection that makes raw water drinkable. It starts here at the source. Our source water could be from surface water like rivers, lakes, and streams, or groundwater, the aquifers that lie beneath the earth. Public water supplies tap in these sources to provide us with our drinking water. So before being distributed to us, raw water from catchments must be made drinkable. The necessary treatments are carried out in drinking water production stations, which do not all perform the same work. Successive treatments must be appropriate for the water resource concerned. In fact, depending on its origin, its environment, and the environments it passes through, water is loaded with different elements, mineral, pollutants, etc., natural or not, which modify its composition. Depending on the quality of the water withdrawn, the production of drinking waters requires different stages, involving 4 types of processes: physical, chemical, physico-chemical, and biological. A drinking water production station generally treats surface water by means of the following type: coagulation and flocculation, sedimentation, filtration, and disinfection. During coagulation, chemicals called coagulants are added to untreated water. These chemicals, such as aluminum sulfate or ferric chloride, when mixed with the water causes the tiny particles of suspended solids such as clay or silt to stick together or coagulate. These groups of particles then join to form larger, heavier particles called flocks, which are easier to remove by settling or filtration. Once the flocculation process is complete, the water then passes over the weir in the flocculator and travels to the center of the clarifier or sedimentation basin. As the water makes its way toward the weir, the large flock particles are allowed to settle out to the bottom of the clarifier. A rake continuously travels across the bottom of the clarifier and scraps the settled flock to the center of the units. Pumps are used to pull the settled sludge out of the clarifier and send it to a disposal pond. The water that passes over the weir is collected and transferred to the filters. The reason clarification occurs before filtration is so the majority of suspended material can be removed prior to filtration, which avoids overloading the filters and thus allowing much more water to be filtered before the filters must be backwashed. Clarified water enters the filters from the top. Gravity pulls the water down through the filters where it is collected in a drain system at the bottom of the unit. There are many different types of materials used in filters, the most common being sand and gravel. Many conventional plants are now using granular activated carbon as the media of choice because it's not only provide excellent mechanical filtration of particulated matter, but also removes organic compounds which can cause taste and odor problems. Once the water has gone through the filtration process, it is about as clear and clean as it can get. However, there may still be bacteria and viruses remaining. To ensure these are destroyed, there must be a disinfection process employed. The most common disinfection process used in the United States and Europe is chlorination. Chlorine comes in many different forms, including chlorine gas, the most common, chlorine dioxide, hypochlorite or bleach, and others. Whichever method is used, chlorine is added to the water in an amount to ensure all microorganisms are destroyed. Water plants monitor the chlorine levels continuously and very carefully in the treated water. They must add enough chlorine to ensure thorough disinfection of the water, but avoid adding excesses that can cause taste and odor problems when delivered to the consumer. Once the disinfection process is complete, the water is stored. Storage usually takes place in elevated storage tanks that are visible around town, or in an underground storage tank called a clear well. And also, there must always be an ample supply for water available in the event of emergencies. Distribution. So, the question now is, how does the water comes out of our kitchen tap? The stored water is pushed through underground pipelines all over town in what is called a distribution system. The distribution system consists of large water pumps at the treatment plants, overhead water storage tanks, large pipelines, smaller pipelines, fire hydrant valves, and water meters in our front yard. At this point, and for the sake of brevity, we focused only on the most common potable water treatment techniques. But there are tens, hundreds other deviations we haven't discussed, and which depends on the raw water origin, environments, and environments that passes through. Thank you for watching. If you enjoyed this content, don't forget to like and subscribe. Thank you and see you soon.